Hello and welcome to the implementation of iteration number 5. The goal here is to calculate the score and to update and display the statistics. So let's go ahead and start. So to calculate the score, the first thing as you watched in the overview video is to define a variable to retain the correct answer. So I'll say variable correct answer counter, and this will be an integer, and we're going to initialize it to 0. And then we also say variable score, and I'm going to say this also is an integer. I know in the overview I said that this would be a float, but I think I'm just going to use it as an integer to make it easy to display the result. You can keep it float. As I said in the overview, you can calculate the score really any way you want. So the correct answer counter will need to be reset every time you play the game. And following the spirit of organizing our code in the start game, it should not really worry about resetting the number of turns or the correct answer. We should delegate that to a function called the reset game. So I'm going to add a function to reset the game. And instead of saying turn counter equals 0, resetting the turn counter in the start game, I'm going to reset the turn counter here. So reset turn counter to 0, and I will also reset the correct answer counter to 0. So every time you start a new game, you are resetting the correct answer counter. So I will say reset game and modify my comment to be reset game. So at the start of the game, we do two things: reset the game and then play the game. Reset the game, we set the turn counter to 0, so we are starting another game from 0, 1 to 3. We set the correct answer counter to 0, so we are calculating a whole new score. In the play game, we reset the turn, check the number of turns, and either go to play random note or go to end game. In the end game, we construct the end game alert, and in the check answer, we identify or decide if the user answer is correct or not. So in the check answer, I check here if the user answer is correct. If it is correct, I display the correct answer and I set the alpha of the correct answer image, and then I need to increment the correct answer counter. So I say correct answer counter plus plus. I mentioned the plus plus concept here when we talked about the turn counter. Plus plus, it increments the variable by 1. So if the variable has 0 to start with, the operator plus plus increment that by 1. So it's a shortcut or a shorthand. So we say correct answer counter plus plus. So now we did the first implementation. We got the correct answer counter. Now we need to calculate the score. So in the end game, I'm going to calculate the score. And I'm going to do it before the alert controller because I want to display the score in the alert controller. So I'll say here, calculate the score. I say score equal the correct answer counter. And I'm going to multiply that by 100, then divide by the maximum turn. All right. Then I need to display that score in the message. So I can say game over in the message, the string of the message, and inject the score. Or I could take this entire string and make it an expression in a variable. So I'll say let message equal and put the entire string there and format it in a more sophisticated way. And then instead of using the message game over, use that string. Here I'm just gonna leave it in there I'm not doing a sophisticated message or anything. Game over, score is, or your score is. Yeah, I forgot I need to say your score is. Perhaps I don't even need the game over. I'm sure you will come up with a better message than me. So here is your score, and here is the calculation of the score. So let's try. So we start again. Let's do all correct answer. So the score here should come back 100%, and that it is 100%. I probably need to add a percent there, or maybe you can leave it 100. Then let's play another game with no correct answer. So the score is 0. Now if you play one with just one correct answer, and then we keep the others incorrect, we should get a score of 33. And then we can keep doing that for the other case, two correct answer and so on. So now we calculated the score. We should go ahead and update the statistics. So where do we update the statistics? We need to update the statistics every time a game is played. So every time you calculate a new score, you update the statistics, which means here inside the game function, the end game function. But the end game function has a different purpose than the updated statistics. Then we should put updated statistics in a function of its own and call that function from the end game. So I will come here right after end game and define a new function, and I will call it update stats and define the function block. And in the end game function, right after I displayed the alert inside the end game, I'll say update the stats and say update stats. So the end game now calculates the score, displays the alert, and then updates the stat. In the update stats, we need to do three things. Retrieve the stats from the user defaults, update the stats based on the current game results, and then save the stats back to the user defaults. So three things: retrieve the stats from the user defaults, update them, and then save them back. So how do we retrieve it from the user defaults? First, get a reference to the user defaults. The user defaults is managed by the operating system, something like the bundle of the app. I don't know where it is, but there's a library called NSUserDefault that can give me a reference to it. So I will say let, and you can give it any name you want. I'm gonna call it shared object because it reflects the objective of this object. The user default is the object that will be shared between these two screens, or you can call it user defaults, anything you want. The library name is NSUserDefaults, and it has a function called standard user defaults. The standard user default returns the shared defaults object, as you can see in the description. Now that you have the shared object, you can use it to retrieve the different stats. This is a key value. Remember in module number 3, when we had a dictionary, we could retrieve a value for a key. We can also add a value with a key. So you can add a new value. We didn't do adding a new value in project 3 because they will load it automatically from a file. But here we have to, but here we will retrieve the same way we retrieved before, and we will have to save it in number 3 to set its value. So I say here var highest score equal. This highest score is just the name I gave it to a variable to represent temporarily the highest score. Then I say shared object, and then I need to get the value for key, or I think you can do float for key. So if you have a number, you can just use float for key and it gives you back a float. So I don't have to get value for key and convert it to float as I did in module number 3. The float for key, it requires a string, which is the key name. So we need to decide what we're gonna name the keys. So I will name the keys with the name highest score. Now you will ask me, well, but I did not save a highest score key into the user default. So the very first time this app runs, highest score will say the shared object will not have a key called the highest score. And I say yes. The first time you run this app, unless you do it in the view did load, there was no assignment or no creation of a key called the highest score, and it definitely does not have any value associated with it. And in this case, a shared object will return a 0. So if it goes to the if it goes to the shared object, searches for a key called the highest score, and it's required to return a float, it will return a 0 because there is no float. There might be, since I have integers, there might be an integer actually, since I have the score as integer, yeah. And I'll probably should use that because the int, that's the same type I set the score to be. So I'll use integer for key, and the key is highest score. Then I need to do the same for the lowest score. So lowest score equal shared object, integer for key, lowest score. Then I need to do the same for the recent score. Actually, I don't need to do it for the recent score. Number of games, and then I say shared object dot integer for key, number of games. The reason I don't need to do it for the recent score, because updating the stats based on the current game result, the recent score is the current game result. So I don't need to check it or anything like that. I even don't need the number of games as well. So delete that. Or actually, no, I need the number of games because I update that. All right. So we got all the statistics, the historic statistics. Now I need to update it. So how do I update it? Well, let's start by updating the recent score. So I say var recent score equal score. The current score of the most recent game automatically becomes the recent score. So how about the number of games? Since I just play the game, the number of games automatically gets incremented by 1. Now how about the highest score? The highest score is not going to change automatically. The highest score will only change if the recent score or the score from the current game is higher than the historic highest score. Only then we update the highest score with the recent score. So if your highest score was 33 and your current game gave you 66, this means that you need to change the highest score because now there's a new value, a new maximum, a new higher score. So we'll come here and say highest, if was to make that comparison, we check. So if highest score is less than score, if that is true, if this is true, if this is true, then we say highest score equal score. Then the next one is the lowest score. So the lowest score is a bit tricky. You can do the same thing. If lowest score greater than score, if that is the case, then you set the lowest score to score. So if the score that we have in the most recent game is greater than the lowest, is less than the lowest score, then we have a new low, and then we assign the score to the lowest score. The tricky part of the lowest score is that the very first time when you first play the game, the lowest score is gonna set to 0 because this shared object is going to go to the standard user default, search for an integer for the key called lowest score. But it's not gonna find a key called lowest score the very first time the game is played. So this lowest score will carry the value 0. But that's not a true 0 because the 0, you can play the game and score 0, but that's not a 0 as a result of playing the game. It's a 0 as a result because we haven't yet started. That's the initial value. So the other thing is that if the score is 0, there is no way the lowest score will be lower than that. There's no way you could ever get the actual lowest score. So in order to make this work, we need to set the score to the lowest score, either if the lowest score is greater, or which happens if the game has been played, or if the number of games is 1. So if the number of games is 1, it means this is the very first game that is being played. And if that is the case, then the lowest score should always be the current score. Because the very first time you play a game, if you only played one game, your highest score, your lowest score will be the same, and that will be the most recent, the score that you achieved in that first time you played the game. So I need to modify that condition. So I used multiple conditions here, but all the conditions I have used so far are were single conditions. So I can use multiple conditions, or what we call binary conditions, by adding a logical operator. So the logical operator here is OR, which is the dash, the vertical dash, OR, and then we say number of games equal 1. What's happening here is that you have two conditions, and I combined the two conditions. So this condition can evaluate the lowest score greater than score, can evaluate to a true or false. And the right conditions, the number of games equal 1, can also evaluate to a true or false. By combining them with the OR operator, we say that if the lowest score is greater than a score, or the number of games equal 1, the lowest score will be scored. All right? So with the OR operator, it is enough that one of the two conditions is true for the entire expression to be true. So now that I updated all my 4 statistics value, I need to save them back to the user default. So I say shared object dot set integer. So the set integer will allow you to add a key value pair to the shared object. So it asks you what is the value. So we can start with recent score. And what is the key? Recent score. Then we do it again. And the value here will be highest score. And the key will be highest score. And the key when we save them has to be the same as the key when we retrieve them. Otherwise, you're not going to get the value. So be careful with that. Then we have shared object dot set integer and lowest score, and the key is lowest score. And then last one, shared object dot set integer and this will be number of games, and the key is number of games. Notice there is a note here, and Xcode has realized that we never really changed recent to score from the first time we defined it. So it is suggesting that since you never really changed this value, maybe you should use it as a constant, which I agree with Xcode in this case. So I'll just follow the fixed suggestion, replacing var with let, and Xcode is now happy with us. So if I run the game this way, you're not gonna see any change, any difference, because what I did is, oh, actually you see this, we did test the score, but the statistics part is all behind the scene. I saved it now to the shared object. For this to really to see the effect, I need to retrieve it and display it, and I'm going to display this in the statistics screen. So in the statistics screen, I will need to have something to display it on. So maybe I'll add a label. You can add one label with 4 lines, or you can add 4 different labels for each one of the scores or the statistics. So in the utility area, we're going to get a label, and you can decide, you can either have one label with 4 lines, and you can construct one string with 4 lines. The problem here is you won't be able to change color. All of them has to be the same color. Or you can have 4 different labels, and you set the string for each one of them. And that's what I'm gonna do. I'm gonna have one label for the lowest to score, one label for the highest to score, and one label for the recent to score, and then one for the number of games. And all of them, I don't want data in all of them, and I'll just leave the colors the same. If you want to change them, change the colors so they look different, each one of them. Then the next step, those 4 labels, I need to connect them to the statistics view controller with as outlets. So switch to the statistics view controller, which is currently empty. So these are all of them. So we'll start with the first one and define them inside the class. So I will call this label highest to score. And I take the next one, and I'm going to call it label lowest to score. Then I'm going to take the third one, I'm going to call it label recent score. Then I'm going to take the last one and call it label number of games. Then in the view.load, I need to display the score. So step number 1, retrieve the stats from the standard user defaults. And I'll probably need to get rid of the assistant editor. I no longer need it. And then assign the values to the labels. So retrieving the data will be very similar to what we did in the game screen. So first we need to get the reference to the user default. So I'll say let shared object equal NSUserDefault dot standard user default, and then retrieve each one of the 4 items that I assign. So let highest to score equal shared object dot integer for key, and the integer here is highest to score. The key has to be exactly the same as the key I assigned in the game screen, and it's case sensitive. So be careful with that. if the statistics come out 0, no values in them, know that you made a mistake in the name of the key. So go to the game screen and this one and check that the key matches everywhere. So let lowest score equal shared object dot integer for key, and the key is lowest score. And then the last one, the third one, is recent score shared object dot integer for key, recent score. And then finally, number of games shared object dot integer for key, number of games. And then finally, assign the values to the label. So I'll say label highest score dot text equal. Now you became experts with label, so you should be able to do that. You can use the localized string with format, or you can inject the value inside the string. So I can say here highest score equal, and then inject the value by using parentheses after a slash and say highest score. And then I say label lowest score dot text equal lowest score equal, and then inject the string value lowest score, not the string value, the integer value. And then label recent score dot text equal, you can say recent score equal, and the value recent score. And then finally, the number of games dot text equal number of games equal, and the number of games. So I retrieved the values, the keys and values from the shared object, and assigned it to the label text property. So let's see. So we start again. Let's give some correct answers. So I got a score of 66. If you go to statistics, you can see now the highest score is 66, the lowest is 66, the recent is 66, and we played just one game. So let's play another one and maybe make just one correct answer. So the score is 33. So with the score 33, the highest score is not going to change, but the lowest score will change, and the recent score will change, and the number of games is now 2. You can make another one and get everything correct. So that means that the highest score now changed, the lowest did not change, and the number of games became 3, and so on and so forth. So now you have all the parts of the game are working. We have some enhancements that we need to do, and we'll do that in the next iteration. Some of the enhancements, when you play a game, notice you can keep clicking on this button, which resets the game every time and play a game. Keep playing the game. The idea is that when the user clicks start game, they should not be able to click it again. When the user selects an answer, they can click it and keep clicking on any one of those buttons, which results in showing multiple of those views, because when you keep clicking, every time you click on the button, we are launching a scheduled timer after 3 seconds to call on the play game, which will notice that there are no more turns, so it's gonna keep presenting that game end. So what we need to do is to disable all those buttons and enable them only if the user wanted to, enable them only when the user need to click on them. So in the next iteration, we're gonna learn about how we enable and disable buttons. We learn how we can, where in the code we can go and make those changes. We're gonna also introduce the iteration or the looping construct, the for loop construct, and finally play a little bit with the colors for the labels. There are a lot of features you can add to this on your own. For instance, you can add play again, so that when the sound is played, the user can play it again and hear the sound one more time. So thank you, and this part concludes the required part of this project, and the next iteration is an optional iteration.